A lot of drivers ask me how to correctly set up the steering system for the T4. And we now have the T421 here. The steering system is the same as before, but we have the optional 8mm Ackerman plate now included in the kit, which is used by the team quite often. And in this video I'll explain how to set up the steering to have equal steering lock to left and right, and where to mount the recommended shims and how that will affect the steering. So follow me. So the car that you see in front of you has been built according to the manual. This means that we have this link here as short as it possibly can be. I tightened the turnbuckle all the way down so that it's just 18mm of length. And this will give the servo horn an angle towards the center of the car. Not at 90 degrees, but it's probably at 11 o'clock angle. That's usually how I set my servo horn. We got 4mm of shims here and 5mm of shims at this point in the center. These two distances are important to get right so that the steering link has the correct angle. And then of course the steering links, their length is affected by the suspension settings. So for example, if you change the track width here with different inserts, the lengths of these links will change, or you will have to change them to adjust accordingly. It's important that they are always the same length, left and right. So now I have the kit base setting. So I have the center suspension inserts front and rear with 1 degree of toe out and 2 degrees of camber. And then the steering links are 26mm per side. 26, that's the kit setting. You can check the toe out here. Let's center the steering. 1 degree and 1 degree per side. We then check the steering lock. It's important when you set up the steering lock that you set it up so that this point here is not pushing towards the steering arm. There cannot be any tension here, because if it's got tension here, it's gonna affect the flex of the car, because it's gonna bind up when the car is cornering. So it's very important that when it's at full lock, it's just touching against it. It's not binding up. This cannot be binding up. Make sure that you set the EPA on the radio so that it's not binding up on either side. It has to be moving freely. You can check this easily by doing this. You turn it fully. Check that it's got a little bit of play on both left and right steering knuckle. It cannot be tight. Here it's actually on the tight side. I need to reduce the EPA here by 1 or 2 steps. As you can see, it's a bit tight, so we're going to reduce the EPA. To the right by 1 or 2 steps. One more. Now we got a little bit of play and it's all good. And we're ready to check the steering lock. Put the setup gauges back on. We check the toe out. 1 degree per side, all done. And now we can see the steering lock here. 26 degrees on this side. And 26 degrees on the other side as well. That means we have equal steering lock, and that's exactly what we were after. If it's not equal, there's several things that you need to look out for. For example, you may need to retighten the screws of the front suspension. Try to undo these screws and retighten them to make sure that everything is lined up properly. Because if the suspension is tightened down at an angle, you may have these blocks pointing towards one side, and then you might need to make one of these links longer to compensate, but that's not good for the geometry of the car. So it's better to loosen the suspension and retighten the screws until you get it right. And that's the first thing I would check. On rare occasions, steering block can be slightly bent, or these ball studs can be threaded into the steering block at an angle, which means that these steering links will have different lengths. So you need to pay attention to these things as well, if the steering lock's not equal. And as I said before, when you put the setup gauges on, make sure that you spin the transmission a couple times to get an average value. The same goes for the camber. So I hope you got a good idea of the basic setting, the kit setting for the steering, and you know how to set it up. But is 26 degrees of steering lock enough then, you may ask? The answer is yes. For most conditions, 26 degrees is just enough. Especially for the stock class, it's important to not use too much steering lock to scrub speed in the corners. And since we moved to the mid-motor type of car, the car has more natural rotation, so you actually don't need as much steering lock as you would on the old car. But if you desire more, we offer these optional aluminum steering arms, which they replace the kit plastic arms. And with these arms, because they're a bit narrower, you can get more physical steering lock. You can get up to 29 degrees of steering lock when you switch to these arms. You also get a bit better steering response because they're stiffer. They don't flex as much as the plastic arms. So I can really recommend these for better steering response, and if you want to try and achieve more steering lock. Most of the team drivers, they prefer these arms over the kit plastic ones, but we actually limit the steering lock then to 26 still by using a larger diameter washer for the center point of the steering. Keep in mind that when you change to these optional aluminum steering arms, you'll have to reset your EPA. You have to redo the procedure that I've just gone through. So it has to be done again to be able to set it precisely. One thing which happens when you put these on is, as I've just said, you get more physical steering lock. So how do we counter that? If we don't want more steering lock, we just want to use the benefit of the stiffer arm. So if we want to retain 26 degrees of steering lock, we use a larger diameter shim at the center point of the steering. The kit shim is 6 millimeters of diameter. That will give you, with these arms, 29 degrees of steering lock. So if you want to limit the steering lock to 26, you should use a optional black shim, which is 7.5 millimeters of diameter. So I use 2 of these, and I add one other size shim on top to make the height. So these are 1.5 millimeters. You need 2 of these, and then 2 millimeters more on top to make the 5 millimeters of height, which is standard for the center shim. So this limits the steering lock physically at the arms in a very precise and easy way. So what about the servo horns? The car comes with a servo saver, which is a really good option for club racing or for whenever you race on tracks with boards where the servo is vulnerable to damage. And for most customers, I recommend to use a servo saver because it's really strong. The XRAY servo saver is pretty stiff, so it will not hurt the performance of the steering very much. But if you want no compromise to the steering response, as we do for a high-level competition, I recommend using a direct servo horn. So from Hoodie, we have different types of servo horns. First of all, we have different types for different servo splines. So 23, 24, and 25 teeth servo splines. We have 2 options though. We have the 2-hole one, where the tallest hole is 19 millimeters of height from the center. And we also have the single hole one, which is also referred to as the offset horn. It's just 16 millimeters. So how does this affect the handling? With a taller hole, you'll need to use less steering input to reach the desired lock. So basically it makes the steering more responsive, more direct. The car will be a bit more difficult to drive, but it will feel more reactive on the track. With a lower hole servo horn, the car will be feeling a bit more linear, will be more forgiving, because you'll have to turn the wheel more to reach the same steering like with a taller horn. So it makes a really big difference to the feel, and you'll have to fine tune it for the track conditions you're racing on. I personally recommend the offset horn, the lower horn, for really high grip tracks where you need to smoothen out the car and make it easier to drive. And for all other conditions, I recommend the 2-hole horn. As you can see, these horns are also clamp type servo horns, so you can tighten down these screws here to give extra security. But also, when you tighten this screw down, you lock the servo horn more tightly onto the servo spline, so it actually helps to improve the steering response as well. So if the spline is not perfectly sized for the horn, the screw will help it react better when it's perfectly fitted on there and when it's perfectly tight. So depending on the servo you use, this can have a big benefit as well with a clamp type horn. One piece of information which is important to know is that when you use the top hole on the servo saver, that's 19 millimeters of height, so that's the same height as the top hole on the 2-hole servo horn.